So I just really want to remind you quickly in a matter of 5 minutes of what we covered so far in the last lecture. So in the last lecture, we start a new topic, and it's about photogrammetry, which is the inverse of photography. So we simply introduced for you the meaning of photogrammetry. We also looked at a few applications of photogrammetry which can be used in architectural documentation, in creating maps, and even forensic for police, investigation. Anything when you want a 3D model, then photogrammetry is a one way to create a 3D model. We also looked at the advantages and disadvantages of photogrammetry. Looks like there are lots of goodies over there and very, very minor disadvantage. One of the most important topic that we discussed last class, which I want everyone to know and understand, is that map is not a photo is not a map. A map is orthogonal projection where it has only one scale all over the map and it has no distortion, which we call it relief displacement. While a photo or an image is a perspective projection, the scale varies everywhere on the image depending on how far the object from the camera. And then finally, the image is distorted. It has something called relief displacement, where things are shifted from actual location due to height or due to distance from the camera. So photo is not a map, map is not a photo. And then we looked at different kind or special kind of photo called an orthophoto. It's a photo that we have done something, some sort of magic to remove the distortion, the relief displacement, and we're able to create a relief-free photo. This one, it's called orthophoto, and this orthophoto right now is equivalent to map, is even better because map, it has no color information, while photo, it has a lot of color information. We also talked about photogrammetry in terms of development. So although photogrammetry is available for us for the last 170 or 180 years, however, there is a significant development started from early 20th century. So this went into the analog era, then from the analog era went into digital era, and then, into analytical era, and then finally, starting year of 2000, we are into the digital era where everything is digital, where you collect your image using digital camera. Your computer will simply go into the image and figure out some stuff and create for you your 3D model. This is something which is available in 2020. I need to remind you that there are a few reasons why in 2020 we're able to do that. Okay, I think we mentioned a few of them. We said drones is one of the factors that kind of give a big push to photogrammetry because now we have a cheap platform that we can fly and we can apply photogrammetry on a different scale. So not necessarily that we need to map the city of Calgary, but we can fly a drone that can simply create a map for a subdivision or even a single house. So photogrammetry right now, it becomes more widely acceptable and cost effective for even small scale project. So what drone is one thing. The other thing is the advancement in hardware. Hardware. So our hardware becomes faster. Our storage becomes immense. We have terabytes of data right now that we can store. The power of computation is super huge right now. Now we have processor, which is i9, it's 11th generation. Those are very fast, and because photogrammetry, as you will start know today, it requires a lot of calculation. Then we need something to do that very fast. And also we have development in algorithm where we have computer vision and artificial intelligence that allows us to automate the process. So ever since the process of photogrammetry was done manually, so a user will have to go and look at the image and click, 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 click on the image. So this was very time consuming, although it was done in the office with the comfort of, of temperature and office comfort. However, it's still very time consuming. And today, most of the operation will done in automatic way, where the software is smart enough to read through the image and find some interest point and match them together and create for you a 3D model. So this is the history of photogrammetry. Also, the way it works is, we already mentioned it, it works by taking overlapping image. Remember this name, huh? Overlapping images. Not really an image that it's taking to one direction and then another image which has no business with the first image and we create a 3D model. We said no. In order for you to create a 3D model, one of the basic rule is the area must appear in at least two photos. Just like your eye, you have two eyes which enable you to see in 3D. If you have one image or your area is covered by a single image, it's impossible for you to create a 3D model. Okay? Actually, there is a way, but it's not accurate, so I'm not going to get into this, but there is a way to create a 3D model from a single image based on shadow, but again, that's kind of computer vision. Computer vision, so you know, it doesn't really focus on accuracy. They want to create just a shape. That's in computer vision. In photogrammetry, we would like metric, like measurement that it's accurate. So that's why the rule is, in photogrammetry, we must have at least two photos covering the same area. And this means my photos must overlap. If the photos are overlap, then we can locate a point in space by something called forward intersection. So we create kind of three-dimensional lines, and those lines, they simply locate the point in space. This is as simple as I can do it, and hopefully I'm going on a high level, because if I show you the mathematics behind the photogrammetry, I think probably you will quit CVT. Okay, but again, we don't have to go deep into the math. We can go on a very high level, and we can still use the magic of photogrammetry to create wonderful product for us. You can see on my screen, there is a last item which we never even touched, which is called in-class exercise. Now, in-class exercise, if you go to the last page of of the first presentation of photogrammetry, you can see here, there is something called Mesh Room, and Mesh Room is a free software, and I used Mesh Room in my class for the last few years. However, I'm having bad time, like, since last semester. I don't know what happens. Looks like SAT is not purchasing some kind of laptop, which there is a hardware incompatibility. Okay. So the thing is, the photogrammetry, because it requires a lot of calculation, so this will take forever. And that's why one of the things, people invented, which is amazing, called the parallel processing. Parallel processing. It means the second calculation doesn't have to wait for the first calculation to finish. We can do the first and the second and third simultaneously, parallel. Okay, and this is done not using a thread. If you know about computers, probably you know what I'm talking about. Okay, so there is a kind of a thread. Even right now we have a quad processor, and we have even more than quad processor. So those processor, it means every processor can work on its own, can finish some calculation on its own. In photogrammetry, as I said, some of the calculation are sequential. It means we have to do step number one, then step number two, step number three. But some other calculation, it can completely be done independent. And that's why parallel processing is so useful. You guys remember, I think in the last class I discussed about gaming, like gaming. When you do gaming, what happens? When you do gaming, what happens is you need to re-render the scene very, very frequently. And that's a lot of work for the computer to do. And again, if you are installing a game on an old computer, what happens? Anybody is a gamer here to tell me what happens if you install a new game on an old computer that's not designed for gaming?
You get really low frame rate usually.
Yeah, you get like a frame, and then you wait and a frame, and it looks ugly, doesn't you don't enjoy. So how scientists solve this problem? they create called GPU, which is graphic processing unit, which is in your graphic card. And this has lots of processors, not only one or two or four. It has lots of processors. They can do the calculations in parallel. And that's why, anyway, so bottom line, I don't want to go into this details of IT and computer. Bottom line is Mushroom is designed with GPU. So it means if you have a computer at home that's used for gaming, you can install Mushroom. It work like magic, okay? Very nicely. However, set laptop, they don't have those expensive graphic card, and that's why we have trouble running them last year. So this year, what I did is I simply change and try to figure out another software which also free, so you guys can use it and entertain using photogrammetry and create a 3D model. It will be, if trust me, if you do that yourself, it is going to be very entertaining. And I encourage you guys to do it yourself, not only based on the data set that I'm providing. So I'm going to walk you right now through the data set and where you can find data set. However, if you collect your own data set, like let's say you have an object at home, anything you like, for example, a vase, a shoes, anything you like, you can pick up your cell phone and go ahead and take some photos overlapping, and you can use it to create a 3D model for this thing. So probably let's get started right now. So I want you to go to D2L. So if you go to D2L, and on D2L, let's go to surveying course, and let's go to the content. So on the content here, you can see there are lots of information available. So you can see last time we finished already part number 1. Today I will do my best to look at part number 2. Probably I can finish, probably not, but whatever. But here we go. So I provide you guys here with a 3D Zyphyr tutorial. So please go ahead and download this one right now. Okay, so download the tutorial, because as I said, Mushroom, we have problems because of incompatibility with the hardware, and that's why I chose Zyphyr to show you how photogrammetry works. So let's go ahead and download the tutorial. Tutorial is just a PDF file that gives you an introduction and take you through the process until you find or create your 3D model. And on the same time, also download this data set. So there is one data set here. It's called Devonian Garden Wooden Mask, which is, you guys know, Devonian Garden is in in downtown in TD Square. I collected some data myself, and I will show you today how to process the data. Also, if you are interested, there are many data sets available on the D2L, sorry, available on the O drive. I typically don't use O drive for data transfer. It's just because the files are big, so we have lots of data, and I have so many sample images, and that's why I uploaded them to the O drive. And that's the only time I will ask you to download anything from O drive. Okay, so if you go to the O drive, I'm not sure if any one of your instructors still using the O drive.
Dave Thompson still does.
Okay, yeah, I mean,
Unfortunately.
we agree on O drive only for huge files, because those are not really good to use them on D2L. Anyway, I'm saying this is first and last time to download anything from O drive. So go to student, and then go to construction. Then you go to instructors, and then you go to T, which is Tahir Hassan. So I'm on the top of the list of T, Tahir Hassan. And then you go to shared data. And then those are the courses I taught in the past. So we go to survey 3 to 5. And under survey 3 to 5, there is a photogrammetry. And then other photogrammetry, there is images. And here we go, we have those data sets. You know what I will do, to be honest, I will just copy this link and just paste it here in our chat. So it's for everyone. You don't have to memorize this whole thing. So here is the link. So under this link, you can see we have 1, 2, 3, 4, 5, 6, and 7. Those are data sets for different objects, for a doll, for a sleeping lion, for a monument, for building, and so on. So again, to be honest, I better ask you to do the, capture your own photos. But again, if you don't have good cameras or you don't want to use your cell phone, you can use one of these data sets. Okay, now let's go ahead and show you the tutorial that I provide here on the Zyphyr. Again, I did this over the weekend and I'm hoping it's going to be okay. Just go through it, and if you have any comment, just feel free to communicate with me. I will be happy to edit and modify. So guys, you know what, without further ado, it's as simple as, photogrammetry. Here's what it does. How many software we have? I can tell you. If you do the search, you will be overwhelmed by the amount of how many software that's available in the market. Okay, I just am listing here some of them, and I would tell you every few months there will be another one coming. Okay, so I here listed some of them in green here. This is the one that we're going to use. As you can see, the software, some of them, they are free of charge. Generous effort from practitioners and scientists to do a lot of programming to create those software. So we have a Zephyr, and we have Mushroom, Visual SFM, Regard 3D, and probably there are more free. I give you here the links if you are interested. But you know what? I'm not gonna, to be honest, I will give you the juice. So I have been in the hunt of a free software for how many years right now, and what I give you is the best. Okay. So Mushroom works fantastic, very nice software. Again, if you have at home a computer for gaming, please do go ahead and install this one. If you have a normal computer, just use Zephyr 3D and it will work nicely. Now, for the bait software, there is something called Bix4D, and I put it here on the top because it's really on the top. Like Bix4D is kind of a industry standard, I would say, and there are some other competitors for Bix4D, which is called Capturing Reality, Agisoft Metashape. Also, Zephyr, it has its own paid version of the software. Really, Bix4D comes on the top because it works nicely with drones. And so, but those you need to pay. So you know what, like we don't have to, to do that. Just, make it simple, use a free software, and we're good to go. Okay. Uh, Now, so as I said, I asked you last time to install the Zephyr. Did you guys please show your hands if you did so? Did you install the Zephyr to get ready for this session here? Do you have it ready? Thank you so much. If you've done this, thank you so much. I really appreciate what you're doing. You will enjoy it so much because as soon as we create a meaningful product, you will just love it. Okay, just listening to photogrammetry only, it doesn't give you or expose you to the to photogrammetry as it should be. Okay, so you can see here on my documentation, I'm showing you the steps. So you go here and do the steps. So let's go ahead and start the software. My software, I'm going to start my software. You can see here 3D Zephyr free. I want to mention something that it's free on two conditions. Number one is it's for personal use, so it means you're not supposed to do that for commercial use. Number two, they are smart. They simply place a limit for the maximum number of photos, which is 50. So if your project contains a 50 image, you're good to go. If your project is more than 50 image, good luck. We cannot help you. Okay. I can tell you a small project will have more than 50 images. Okay, so for example, this small wooden mask, I think if I remember correctly, we have total of 47 images, and that's a very small object. The size of this object, to be honest, uh, probably 50 centimeter by 50 centimeter, including the board. But anyway, you can think about it, huh? You think about it. The bigger the object, I need to get more images. And as long as, and you can see it also, there's another factor, which is how far I am from the object. So anyway, let's go ahead and look at how we run the software, which is super simple, straightforward. So what you have to do is You say here, you get this introductory page here where it can take you to some tutorial. They have a fantastic website. They have some instructions and some videos on photography in general, and tips and tricks on how to get the best photo. Again, no thank you, I'm okay. Next is, you can see here, I get my software. The software has one area which will show you the reconstruction of your surface. Right now, since we have no data, it's empty. And there are some other elements of the interface, kind of explorer, like tool space. If you guys remember Civil 3D, like there's a tool space here, but it's not tool space. It's equivalent tool space. It just explore your project of how many photos and what are the steps and so on and so forth. Let's go ahead and start our workflow. So if you go here on your workflow and you say new project, very simple, huh? Workflow, new project. So you can see here, it comes as kind of wizard. Like, what does it mean? It means it will take you through the process. So the software is very friendly. It's just a wizard. You have to go one page, finish one page, next page, and then you are on your way. Okay. So you can see here, the first page is asking about new projects. It's a new project. You will say here, you know what? I need to create a 3D model and then add also a texture. Okay, you can choose, for example, a 3D. So when you get a 3D, it means your surface will be boring without any color. I would recommend you to always add some texture, because that's one of the advantage of photogrammetry, that we're not only getting an XYZ, but also we're getting a more advantage, which is color information. So please go ahead and select those two options. I need to compute a 3D and also compute texture after surface reconstruction. Then there is nothing you can do in here. What you have to do is go next. Now on the next step, very simple. You can just read what's asking here. So photo selection page looks like, where are your images? I need to know where are your images. You can do that using two ways. Number one is you can add an image or several images, or you can simply look at folders. That's up to you, okay? So for example, let's say one of the folders on the D2L, it has 100 image. I'm asking you, I have a folder on D2L that has 100 image. What is the best way to go? Should I add image or should I add folder?
Well, if you're using this version, you can only use 50, right? So you'd have to add the images individually.
Exactly, sir. That's exactly my point, or the trick. If you add a folder that contains more than 50 images, the software will complain, okay? If your folder has less than 50 images, which is our case, which is the wooden mass, then I can simply add the folder and it will grab all the photos in that folder. Okay, you get the idea. Huh? So I'm gonna go ahead here and say, okay, add folder. My folder is simply, I'm not going to go to the O drive. I have the same data available on my local machine. So I click on Devonian Garden Wooden Mask, and that's it. So you click on the folder, you say select folder, and simply you can see it simply read all the photos. As I said, need to remind you that those photos need to be less than 50 or 50 or less. Okay. Good news is we have only, I think, 47. Now, once you pick your photos, okay, you can go next. And just to mention something, you can import your photos from a video. So you guys know that any video is a sequence of image. So the video is nothing more than photos taken at high rate, like 60 frame per second or 30 frame per second. Okay, so the software allows you also to take a video and simply capture single frames from a video. But this is tricky. I'm not gonna recommend you to do that because it's tricky. Tricky in terms of, if you use a camera that has high frequency, like let's say 60 frame per second, when I take two images, which the distance or the time interval is very tiny, it doesn't help you. Remember, the two images, as I said before, we need at least two images, correct? Those two images, they must have a spacing. Must have a spacing. Look at your eyes. You have two eyes, and there is a space in between them. And this has a name already called the base of photography. So if this base is so tiny, it doesn't help you to create a good 3D model. So that's why when you pick some frames from a video, you have to be very careful. You have to leave some time until you move your camera somewhere and you can simply pick another frame. Does it make sense? Does it make sense?
Yes.
Yep.
Okay, thank you so much. Then you can again, and I think there is another option called big frame from Panorama Pictures. Again, really the best results you'll get it from just taking photos separately, like still photos, not really a video. And one more thing, by the way, so you know, the resolution of the still image is better than the resolution of the video, because the thing is, the video, the hardware will have to take 60 frame per second. Can you imagine? 60 frame per second. And the still image, it will take one image until you click on one more time, you take one image. So the resolution of the single still images is better than the resolution of the video. Okay? Now what happens is we're done here, so we go next. As I said before, if you get more than 50 image, the software will complain as you hit next. It will tell you it's more than 50. Okay, so let's go next. And you can see the software, what it does at this stage, it simply read the header. And this discussion, by the way, it's pure computer discussion. So my image, it has a header. The top of every image, so the image is a matrix. So you know, the image is a matrix. Did any of you guys learn the matrices somewhere in your math classes? Matrix,
I
which
think
is,
we used it in Excel.
yeah, you use Excel, but matrix, it has like, you know, like a background. Matrix is as simple as it's an organization of numbers in a organized way, like rows and column, like in Excel. But it has way deeper meaning, and it's used in solving linear equations, stuff like that. And matrix is simply, I'm going to show you. Do you see the background? Do you see the background here? This background here, this is a matrix. You can see it's kind of row and column, row and column. So this is how we store image. We store the brightness number of the color in one location in our matrix. But on top of that, we also add a header. So the header is simply tells you, for example, what is the sensor name and what is the focal height, focal length, and also the size of your sensor. Now, can you please look at my screen? For example, take the first the top line, like where it says camera, and then on the right it says calibration. You can start reading. So on the left here, it tells you the name, the image name, and also it comes on the right and tell you SMG something. So what's this exactly? This is the camera in my cell phone. So that's the name of the camera in my cell phone. Dash 44 millimeter. What is the 4 millimeter? That is the focal length. I'm pretty sure somewhere in your study in physics, so you learn about lens and you know that doesn't mean focal length, huh? So 4 millimeter is the focal length of the lens of my camera. And then finally, you can see 4032 by 3024. This is the size of your sensor. At the back of every lens, there is a CCD array or CMOS, and it's like a matrix of small elements that they can feel the light and they can generate a current with respect to the light. Again, I'm talking about how the digital camera captures an image. Remember, years ago, there's no digital camera. So what was the alternative? So at the back of the lens, there was a sensitive material for light, which simply your film. Okay. Right now, those are almost disappearing, and we're going into digital era where we replace the film by a CCD array. What is the size of the CCD array? Simply, it's 4,032 rows by 3,024 columns. So rows and columns, huh? So just to tell you, okay, this is something called calibration. So the focal length of your lens is not constant. Some of them, they make zoom out and zoom in. And when you zoom in and zoom out, what do? You change the length, the focal length. Okay. Again, this is difficult discussion. I don't want to bother you with it, but every camera has something called calibration parameters, which is the focal length and the distortion factors, blah, 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 blah. Without going into those details, if you're interested and if you love them, here we go. You can go to modify calibration and you can read. So you can see here, there is the sensor, the focal length and there is distortion parameters in radial and tangential and so on. I don't personally want to bother you with all of those. This is kind of a deep discussion, and the software, so you know, during the calculation will re-estimate and improve the value of the focal length. Okay, okay, are we good for now? Let's move on to next step. So the next step is simply we're going here into camera orientation. In photogrammetry, when we take an image, to be honest, we don't know exactly where we take the image. When I say exactly, I'm not saying roughly, I'm saying exactly, like what is the XYZ in millimeter, where was my camera? In addition to where, there is also angles, so your camera can point anywhere in the space, up, down, left, and right. So there are some rotation angles. Those rotation angles and the location of the image are completely unknown, and we have to find them during the reconstruction process. Okay, so this process here, you know what, I'll make it simple for you. I'll show you what are the juicy details. So if you go here and go to, instead of presets, if you go to advanced, so what happens here, it gives you control of more variables of the algorithm. Okay, so if you are advanced user, I would recommend you to go and look at all these parameters. Okay, for example, when I select a density points or interest point, do I need lots of points or low points? And some of you, okay, what's the difference? Why do I need sometimes very high number of density points or key points, and sometimes I need low points? Look at this, please. The more you ask, the more calculation. So just imagine when I go to the very high, the process will take a very long time. When I go to the very low, the process will take a very little time. So you can see here the software is made for a kind of presets. What does it mean? It means look at the blue, or sorry, not the blue, the yellow or the orange. Huh? Right now everything is set to a pre-default, like medium, very fast, medium. So those are the presets. Don't play with them if you are a beginner. Don't play with them. If you are advanced user, then what you do is you go and probably play here, make it very high or make it high or medium. You can do that. Let's go back to preset. So what does it mean? It means please software, use whatever you think it's better for me. If you are advanced, then you simply know what everything means here and you go change it. Then what you do is next. So, and the next here, okay, is asking you density point cloud creation. So the software will create for you a 3D surface. Now the question is, how many points do we need my surface to be so dense or so coarse? Okay, so the opposite of dense is coarse. Huh? Do I need a coarse surface or a dense surface? To be honest, everything has advantage and disadvantage. As I said before, if you need dense point, your software will have to spend hours and hours and hours working for you. If you can live with a coarse surface, then it will do the job very quickly. Okay, as I said, let's leave it as preset as a beginner. Next. Then surface reconstruction, again, there are some settings there. Again, for you guys as beginner, we will just be happy with whatever the software is preset to do. Next. And then we are on the texturing. So again, when we color our surface from the image, there are some setting. Yes, there are some setting. And again, if you're interested, you just have to go here and go to advanced, and it will show you what exactly parameters you can change. Okay. I myself, again, in most cases, your preset values will give you a really good results. Then next, and then this is kind of a final review with you. So you have a total of 43 image. Okay, and those are all the settings you have so far. Can anybody guess what should I do next? You can see my next is great. So if I hit next 1 million times, it doesn't do anything. What should I do?
It run.
Yes, thank you so much. So at this point of time, you're done. You're ready to process your data. So let's go ahead and hit run. You can see the software right now. You don't have to bother. The software will enjoy and do a lot of calculation. And I will show you a little bit. I'll give you kind of a sense of what's going on the background. You don't have to worry about this one for now. You just have to minimize the process, and then I will take you through the process of what the software exactly doing right now to create for you a 3D model. Are you guys ready?
Yep.
Are you ready?
Yeah, we're ready.
Okay, so let's minimize this guy. We don't need it, huh? So let's look at the PDF file. In the PDF file, you can see I try to explain as much as I can, as easy as I can, on how to run the software. I don't think it's difficult, huh? It's just kind of using a pre-setup. If you love photogrammetry and you are going to spend the rest of your life in love with photogrammetry, then in this case, I would really recommend you to go and dig deep and understand those parameters that you can tune to get a better results. But again, for beginner, I promise you, you'll get a very good result. Okay, and you can see. Anybody notice what is my job in this process? What was my job? Did I do any calculation, or the software right now is simply waiting for me to build the 3D model? It's almost automatic, huh? You just have to say, okay, here is the image, here is few setting, and please go do it and go do it for me. Okay.
I do have a few questions regarding the image.
Okay,
does
go
it
ahead.
tell you? Does it tell you how the picture has to be taken, or do you take just pictures, like different angles?
Well, this is a good question. So the software, it's simply process whatever you provide. So if you provide a bad geometry, like bad configuration of photos with minimum overlap or less than desirable overlap, then in this case, the software will fail. And how you see in failing, once you see your 3D model, you will see some gaps. Look, what does it mean? Maybe you will see a hole in the surface. It means the software failed to create a 3D model in this area. Okay? So to answer the question is, that's why you need to learn the photogrammetry. Like for example, and the rules are sometimes are very simple, sometimes are complicated. Like for example, when I say your photos must overlap. So when I hold my camera and take my photos, should I take just one photo and then move very quickly to very far and not covering the first area? Not really, huh? You need to overlap your photos, and it happens through you. You are the one controlling the amount of overlap. If you're using a drone, that's a different business, and probably we hit this point today, maybe. But I'll show you if we fly our drone software. Sorry, the taking the image is controlled by the drone, so the drone will simply drive. Sorry. The GPS will drive the drone to one point and trigger the camera and say, okay, take photo here. Why here, not somewhere else? Because this where is simply where you get your 50% overlap, your overlap percentage. Did I answer the question or still not happy?
No, it makes sense. It's basically like trial and error. You need to try it and see how the pictures turn out when you download them, I guess.
Again, it needs some experience. So photography by itself is an art, and it needs a lot of experience. So I can tell you, maybe your first model will not be as great, but as you do it one more, two, three, four, five times, you will get better and better. And I'm gonna tell you something else, probably not thinking about it. It's not only about the geometry of the photos, but also about the quality of the image. And the quality of the image is super big, like a topic, huh? It's not easy. You can go for a course only for the soul of how to get an image. Like if you, anybody here who's did some photography in the past? No? No photographer in this class? Anyway, so guys, listen, I myself tried to learn as much as I can, which is again, it's a complete different topic, like controlling the amount of light, controlling the amount of shadow, the shutter speed. Like, you need to set your camera, you need to set the shutter speed. Like, guys, the shutter opens, allows some light into the camera, and then very quickly close. If you simply let the shutter opens for a long time, you get something called overflow, what call it, oversaturated image. And remember, the quality of your 3D model is function of the quality of your image. So if you have sharp images, then your 3D model will be a good model. If you have a hazy, blurred images, then your 3D model will follow and will be bad model. Anyway, I'll leave it at this point. I'm not gonna dig deeper, but again, if you are curious about photogrammetry, please feel free to connect with me. I will connect you to so many resources in photogrammetry. Let's go back to here. Somewhere I mentioned those steps for photogrammetry. It's here, huh? Sorry, it's here. Okay, you can see on my screen. So I listed here what are the steps that the software is simply doing right now to create a 3D model full of texture and color. So number one, the software will read the images for sure, will initialize all those variables and read all the images. When I say read the image, it means read the brightness value of every image. And you can see that's a lot of data, by the way. Like if every image is 5 megabytes, so the software will have to read all those pixels and find what is the gray level, what's the color, was it red or green or gray, all of those, we'll read them. Number two, it will try to find some features in your image. And by the way, this is a nice discussion. What does it mean, feature? Okay, feature in your image. I don't know if I have here a right example for you, but let's see. I'll go to here, Devonian Garden, and I will open one of these photos. Okay, and I will try to zoom in to show you what does it mean, feature. You guys know, for example, on the nose here, it's kind of a very smooth, very smooth surface. So we have no feature here. While every one of these small notches into the face, this is a feature point. A feature point is a point that it's easy for a user or for a human to recognize as a very definite point. While you can see on the nose here, there is nothing you can select. It's just kind of a flat color. So the color comes from two things, whether there's an actual feature on the object itself or there's a change of brightness. Okay, that's how the software will detect a feature. Look at this point, look at my cursor. For example, this is a point here. There is a point here. But on the nose, for example, kind of a smooth, there is no feature there. So the software on the first step, what it does, it's simply using an algorithm will try to go and locate those interest points. They have so many names, by the way. Sometimes they call them features, sometimes they call them interest point. So bottom line is we're trying to extract feature from our image. Number two, we will do image matching. We will say, okay, this image is matching with this image. Like, there is an overlap. So image 1 is overlap maybe with image number 20. Image 20 is overlap with image number 22, and so on. So we do an image matching. And then you do feature matching. And what does it mean, feature matching? Please watch my screen one more time. So you can see here, we have an image, and this is taken at the front, just facing my mask. What if I go to a different image, let's say here? I don't know if I can put them side by side. I'm sorry, yeah, it's here. And then I'll do face, so here. I'll put them side by side. So here is what does it mean, feature matching. Now I'm asking you guys, how easy if I tell you, look at my cursor, where is my cursor? Can you find the same point on the left image? So this is a right image, and this is the left image. I'm asking you, look at my cursor, and probably I'll put it, let's say, on the eye here. I'm asking you, is that easy for you as human to go and say, this point is this point?
Yes, it is.
Yes, it is super easy. A kid can do that. If you point to a kid in one image, probably it's easier to find the conjugate point on the other image. But remember, there is no kids here. Look at the software. The software right now is doing everything on its own. Is that easy for the software to do this matching process? Can you answer this question, please? Is that easy or difficult?
Probably pretty difficult.
it is one mystery. It was a mystery for people ever since, like from 1950s when they invented computer and tried to start processing image on the computer until the year of 2000. So people, they came up with lots of ideas, an algorithm to do the matching. So the software will automatically say that this point here on the right image is the same point here on the left image until the year of 1999. I think I discussed this with you guys last class. You guys see this paper on my screen? This paper here, it is by a scientist. His name is David Lowy, and he is from UBC. He is the one, to be honest, probably changed the life of photogrammetry, because this researcher here, this professor here, he came up with this paper, which simply came up with algorithm that simply very, very robust. It can simply tell that this point here is matching 100% this point here. And I can tell you, without going into so many details, this process using computer is super difficult. That's exactly what the software is doing here. The software will simply do the matching, and next is after the software does the matching, which means the point on the left image is the same as the point on the right image, like finding the match, then it will do something called structure from motion. And I will show you what does mean structure from motion here. Let's look at the results. So right now, it looks like reconstruction successful. It means we're done. And let's hit OK and see what happens on the background. So look at this. I want you right now, all of you, to look at what is on the bottom and what's on the top. Can anybody tell me what's on the bottom and what's on the top? I need some help, please. I need you to see the difference between the top and the bottom.
So the bottom's just the images that were taken, and the top is what it turned into as a 3D model?
Yes, sir. Thank you. But I want you to understand that the bottoms are 2D. So those are 2D images are taken from one location, while this one is not 2D anymore. We're able to create our 3D model again. Okay, again, look at this. So we have a 3D model, completely 3D. You can see the depth information. And the beauty is we also have some color information. So we take all those yellowish and brownish colors, and we're able to color our 3D model with it. If you want to see how the 2D, the surface only without any texture, let's turn off. You can see here on the left, there is a tool space where it allows you to turn on and off all the processing steps. You can see it goes from images, go to something called sparse point. So this is called sparse point. And you can see right now it's turned it off. And then you go to dense point, cloud, and it's turned it off. And you can see we create a mesh, and then we create a 3D model. Now it's very interesting to see every product. So let's turn off this model here. So I don't want to see the final results. This is your final results, which means I create a sparse model, I densified, I connected the vertices and create a surface. You guys remember Civil 3D, huh? Because this is somehow connected. You guys remember in Civil 3D, we have points, and then from points, we created a surface. And that's exactly what's happening here. If I show you the dense point, watch this. I'm asking you, is that a surface or our point cloud? If you, the far you go, by the way, they look the same. If you go away, they look the same because the points are so dense, which means you don't see the points. How about if I zoom in? I'm asking you, this is a point cloud or surface? Hello. Is that a point cloud or a surface?
Point cloud.
That's point cloud. You can. These are points. They are not connected by any means. They are not connected. I know that every point has color because it comes from an image. That's why we can paint a brush every point with its color. But at the end of the day, this is not really a surface. This is just a point cloud. So many points. Okay, let's turn off my dense point cloud. Let's look at the sparse. Okay, let's look at the sparse. Watch this. Do you see the difference? Do you see the difference between dense point cloud and sparse? So this is a minimum number of points when the surface is not densified, just a minimum points. So you can maybe, I don't know if you can get the feeling that this is a mask, but I don't think so. Only when you go from sparse point into dense point cloud, then you can start, because you densify, you get more points. And then if we turn off this guy here, that it's a dense point, and we go to our mesh. So this one is not really a point. These ones here, this is a surface where every 3 points is connected by a triangle, and we color the triangle by the color as well. So this one is not really points. This one is a continuous surface representation. And then finally, here we go. Let's turn our last and final and improved product, which is called texture mesh. And so we have now our final product. Now, when we say structure from motion, this is something I already stopped my presentation to look at it. What happens here? Do you guys see those blue things? Do you see those blue things?
Yep.
Can you guess what are those blue things?
Are those where it thinks it took the picture from?
Exactly, sir. That's exactly what happens. The software, as it estimates the 3D model, it also estimates where was my camera. Can anybody tell me in plain language what Tahir did to capture this model? Like how many rows did I go from in a circle pattern from the camera location? Do you see what did I do to create, to take this set of images? Very simple. Just look at the blue blocks, because every block is an image. So I'm gonna tell you the secret, So it's not a secret. Everybody knows. So I stepped on the left side. My camera was high at this location here, and I take one image, and then I moved a little bit to the right, and I take another image, and I keep kind of arcing around my object. Then I lower my camera, and then I want it the opposite way, like half arc, and then I want even lower, and I take a third row here. One thing you notice is that when you click on one image, see what happens? Do you see what happens when I click on one image? It simply takes you your view to where was my camera when I took my image. So every time you click on one image on the bottom slide bar here, then it simply changed the view to one of these cameras. Okay. Anyway, again, if you are interested, you have time, just enjoy the software. There are some capabilities of motion, so you can here add a key, add all camera position, and then you can animate. And you can see here, I'm just animating my scene by going from one camera location to another camera location to another camera location. So that's exactly how I capture my photos, Anyway, so I'm gonna stop this one, and then I will go here. And again, structure from motion is that I'm asking you here, we have something that is static and something is moving. I'm asking you, the wooden mask is moving or static?
Static.
How about my camera?
Moving.
Okay, can I reverse the process? Can I make my camera static? I can rotate my object. Can I do the same thing? Can I get a 3D model if I have my camera on a tripod and I rotate my object and I take so many photos? Can I do that?
You should be able to.
Thank you, sir. Yes, you can. So you can simply move the camera or move the object. It doesn't matter. But the problem is, don't move them at the same time. Don't do that. Never. Because simply photogrammetry will fail. Photogrammetry will fail if you move the camera and the object on the same time. So it's either the object is still and the camera is moving, or the camera is moving and the object is still. You get the same results. Actually, from practical point of view, people, they say move the cameras better because you get a uniform illumination. It has to do with the light. It has to do with the quality of your image. But anyway, this process here called structure from motion, where the software will create the structure, like the surface, by moving your camera. And that's where the name came from, structure from motion. And then after you do the structure from motion, it means you know where all your cameras, and simply you create a dense dense scene. So you're trying to go and densify the points and creating millions and millions of points on the surface. And then the process will keep going, and it includes some of the filtering. So you can see, I'll show you where are the errors can come. We can do that right now. I want everyone to look at the background. You can see, if you have been to the Devonian Garden, anybody by chance have been to the Devonian Garden and know where those guys are? Anyone? Okay, so those guys are at Devonian Garden, 4th floor of TD Square on the east side. You will see some of those wooden masks. They are hanging on a whiteboard. I want some confirmation. Do you guys see the whiteboard on the back?
Yes.
Okay, let me tell you, do you see any problem? I'm gonna take a different angle, because if you face it, you don't see anything. If you see from the side, you will start see some problems. Anybody can see some problems?
Yeah, the white walls starting, or the white piece is starting to blend into the mask itself.
I mean, there are some noises here. It means the whiteboard is flat. You know, the whiteboard is flat. And so it's supposed, if there is no error, it means it will have to show here as a flat surface, which is not. Look at this. Now, the question is why the problem, the photogrammetry failed here. I'll tell you the secret, Photogrammetry needs features. When you have a shiny, featureless surface, it means you get no 3D model. You can see here on the wooden mask, there are lots of features. Look at the cracks. Look at all those like notches in the surface. So the software has done amazing job. The photogrammetry has done amazing job. While in a flat white, no features, nothing. You can see nothing. It can do a good job on the corner because there is a change of color. You can see here the corner is against gray, and so it can find this as interest point. While on the white flat surface, there is no feature. When there is no feature, photogrammetry cannot do anything. And I can, by the way, if you do that manually, even you will fail. I'm asking you, if I go back to my example, those examples here, okay, I need some help. Anybody to show me what is the corresponding point of my cursor? Sorry, let's make it on the left. Okay, I'm pointing here, one cursor on the whiteboard. Anybody to tell me exactly where this point on this image? Any volunteer? Any volunteer? Hello? Can you say yes or no? Can you tell me if I show you here, I take any point on the whiteboard on the left, on the right image? Can anybody precisely tell me where this point on the left image?
Not if it's just in the middle of the weight.
Exactly. So there is no feature here. That's why you fail, photogrammetry fails. There is no science here, okay? How about this point where you have kind of a screw or something or nail? Can you identify this point here on the left image? Yes, you can. And photogrammetry will do the same thing, okay? You can see that the thing is here, Look at this thing, the nail or something. You can see perfectly, You can see it's very nice here. Okay, anyway, bottom line is, guys, there will be some noise. And what happens here, the software will do some filtering, will kind of smooth out all those noises. And that's what you see here on the steps. And then finally, it will simply take all those points and make a mesh, and then finally paint the mesh with some texture. Those are the 11 steps. Every photogrammetry software will go through those 11 steps and simply do to create a 3D model. In every step, I can tell you, there are so many parameters, an algorithm. For example, you can do the depth map using one algorithm or two algorithm or different algorithm. Which one is the best? This is, you need to take a degree in photogrammetry to understand all those little details. Again, I leave it here at a very high level, and hopefully you guys are entertaining photogrammetry by the amount of details I'm providing, okay? So here in my presentation, in my the tutorial, I'm showing you the different products. As usual, and we already went through them. We have a sparse point, we have dense point, we have a mesh, and we have a textured mesh. Okay, now what to do next? Now I have a model, okay? I want to mention something, that this model, which I know for some of you it will look weird, this model is a 3D model, correct? You agree? It's a 3D model. Hello?
Yep.
Okay, so I'm asking you, do you think that has the right scale? Do you think it has the right scale so I can measure some distance from this right now? And you think I can do that?
No.
No, okay, that's the right answer. So you can try this. By the way, the software has more capabilities. You guys are free to to go and investigate and explore yourself. But one of the things you can do here on the software is that you can come here and you can say, I want to measure. So you can say, click on this icon somewhere here, like measure, and then you say begin, and you can simply start from this point to this point, and it can tell you the distance. Anybody can read the distance? It's 14.2. You see the number here? 14.289, blah, 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 right? So this is the distance. Is that right? Like what, 14 what? 14 centimeter or 14 meter or 14 inches? Okay. The thing is, photogrammetry can create a 3D model, but the model will lag the scale. Will lag the scale. It means it's not scaled. However, it's not big deal. By the way, it's not big deal because all I can do is you go to the Devonian garden, if you can do right now, and then you can measure distance from here to there, and you can simply scale the entire 3D model by the same scale. For example, if that's 14 units here, and this happens to be 30 centimeter or 50 centimeter, so you can find the scale, and then on the software, this software, you can scale things up or down. Are you following?
Yep.
So photogrammetry, when you create a 3D model, it lacks the scale. That's easy fix. If you measure one distance, you can scale up and down your object. Now the question is, when we apply this on a surveying, I know that, you know what, I know that some of you will enjoy, but at some point say, okay, wait. Are we really in surveying class? Because that doesn't seem like a surveying class, huh? We're talking about mask and stuff like that. So for some of you, we'll say, okay, that's not surveying class. We're simply looking at mask and vase and doll. Where is the surveying exactly? The thing is, we're creating a 3D model. If you take this discussion and apply it on a like real ground, like, you know, like a subdivision or something, you're creating a map for Calgary. How can we do that? Are we going to measure something, for example, like a distance between 2 points in Calgary, like 1 point in Cedar Brae, and the other one is in let's say at Sate? That's not going to happen. So how can we do that in photogrammetry? In surveying, we simply must have control points. And if you are good at math, you will know if I have control point, like points of known X, Y, Z, it does the same thing. It simply scales up and down your model. Anybody agree to this statement? If I have control point, it scales my my object up and down to have the right scale. Do you agree? Like, for example, if I know that this coordinate here is 0, 0, 0, and this point here is 0, 0 plus, let's say, in Y or Z, it's equal to maybe 10 units or 10 meter. Can I, using the coordinates of these points, can I scale up and down my model? You know, anyway, if you don't get it, you know, sometimes in this application, we measure distance, but in surveying, we simply have to have coordinates. So if I measure this point and this point using total station, which give us metric information like in meter, I can simply scale up and scale down my object. Are you guys following so far? Can I get some confirmation?
Yes.
Okay, so let's move on to our last step, and then we can give you a break, which is simply now, once you're done, what can I do with this product here? What can I do? Okay, what can I do? You can simply export. So the software allows you to export your final product into several formats. One of them is simply writing a PDF. I tried myself, and I was hoping to turn this into a 3D PDF. Anybody of you guys use a 3D PDF before? 3D PDF?
No.
You know what? Like Bluebeam was the pioneer to create a 3D PDF. So it's a PDF, but you can simply rotate and do some measurement. So and by the way, you can cut sections even in 3D PDF. Unfortunately, the way the software writes the PDF is not 3D. It's just an image of what you see on my screen from this view. So it's not really a 3D PDF. However, the other option is you go to export. And when you go to export, there are some formats here, and the formats are something called .ply, .ply, or .obj or glib. So there are some formats here. Really, in my tutorial, I mentioned about object and ply. And why I mentioned those? Because those are very, very, very popular formats in 3D printing. So I can simply turn my project into ply or object, and I can simply go ahead and print this on my 3D printer. Okay, and that's, by the way, that's something very common right now. They do a scan with photos, turn it into 3D model, and then go export an object file or ply file, and then slice it, and then use create or print a 3D object. And the other option is you can host, look at this, you can host this 3D model on the web. So for example, you have a client and the client wants to see the results, you can give them the results through the web. There are some website called Sketchfab, which again, or if you go to my tutorial, if you go down to here, you will see I mentioned for you guys these options. So you can go to Sketchfab, and a Sketchfab, it's kind of a platform where all those people they work with 3D, they can share their models. Now, Sketchfab in general is not a free platform. You have to pay. Only if you accept those conditions, you can simply upload your model for free. What are the conditions? Number one, it limits the size of your file to less than 50 megabytes. And then number two, you must make your model public. If you want to make your model private or your model exceeds 50 megabyte, then you must register and you must pay for the Sketchfab fab. Guys, I think I want to leave it at this point. I don't want to take the whole class. There are some more discussion, but again, for example, you can use the software to scale up and scale down and rotate. But again, that's up to you. You can see here there's translation and then rotation and then scale. You can do that in the software, scaling, translating, and rotating your object. Any question before let you guys go for a break and 10 minutes, and we'll come back for more discussion or photogrammetry? Okay, no questions. Then I will simply leave you for a break. We'll see you back here at 11:19 sharp. Thank you.